Hey, good morning, Algebra 1, period 1, 6, and 7. It's April 15th. Normally this would be a super scary day in the tax world, but this year things are different. So, I'm going to say good morning to everybody. Yay, see, all of your desks are still here. They really are, okay? Kind of wish you were in them. All right. So today, Chapter 8, we're graphing parabolas. I've posted the work out there for sections 8.5 and 8.6. Please, 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 check those before you submit your work. If you have questions, refer to. All the answers are there. A lot of them out there for 8.4 and 8.3 as well. So let's get those wrapped up, and I've posted those two worksheets out there for you. One of them is a factor and solve worksheet, and then the other one is a graphing worksheet. So today I would like to spend just another minute to look at one of the problems from your graphing worksheet. I would like to look at number 15. So number 15 from that graphing worksheet, it looks something like this. So the directions start out with, it says sketch the graph of each function. Well, to do that, you need an axis of symmetry, you need a vertex, you need some x-axis intercepts, a y-axis intercept, and of course when you do this you're going to be super neat. Now, regardless of what you can or cannot find, you need 5 points to graph a parabola. So here's number 15. It looks kind of like that. So f of x is equal to x squared plus 8x plus 18. Note the position of the graph. That's a huge hint of what that number 15 is going to look like. All right? So here we go. So 15, there it is. F of x is equal to x squared plus 8x plus 18. And notice that I have identified a. In other words, a is the coefficient in front of the squared term. If there's nothing there, it's implied to be a 1. The coefficient in front of the x, 8. That's your b. And the number hanging on the end, that's c. Okay, that is your y-axis intercept, by the way. Because if you put a 0 in for x, that's all you got left. So, I would love to find the x-axis intercepts. To accomplish that task, I will set this equal to 0, and I will factor it. Because remember, every y value on the x-axis is equal to 0. So here's the question. Can you factor this? All right. Factors of 18 that add to an 8. All right. 1 times 18, 18, but 1 plus 18, not an 8. How about 3 times 6? 3 times 6 is 18, but 3 plus 6 is not an 8. 2 times 9. 2 times 9 is 18, but 2 plus 9, not an 8. All right, so bottom line is, no, you can't factor this, okay? But that does not mean we get to quit and go home. No, we can still find the axis of symmetry, so let's do it. Remember, the equation for axis of symmetry is x is equal to negative b over 2a, and if b is equal to 8, that means the opposite of a positive 8 is a negative 8, and of course a is 1, and 2 times 1 is 2, and now I get negative 8 divided by 2 is negative 4. So the axis of symmetry is x is equal to negative 4. That'll be a vertical line that goes through the x-axis at negative 4. So what's the significance of that? Well, the vertex is on the axis of symmetry. That means that that x is the x component for the vertex. You need the y. Well, it's there, but anyway, I'll show you how I got it. So you take the negative 4 and you plug it in to your original equation. So now y, remember f of x and y are interchangeable, y is equal to negative 4 squared plus 8 times negative 4 plus 18. All right, well 16 minus 32 plus 18, that's how I got the 2. So now I know where the vertex is. So I have an axis of symmetry and I have a vertex and I have a y-axis intercept. Well, let's graph it up and see what this thing looks like. So, here we go. I got GeoGebra up. I got a brand new projector bulb. Pretty bright, huh? All right, so let's start off with the axis of symmetry. I'm going to go out here to negative 4, and I'm going to draw my axis of symmetry. There it is, folks. The axis of symmetry. X is equal to negative 4. If there's one point on this side, there will be another point on that side. Okay? All right. So where's the vertex? Vertex is at negative 4, 2. Vertex. All right? Now, I would love to put the y-axis intercept on the graph, but I'm out of room. So now I get to pick values for x. I choose negative 3. If you put a negative 3 into that equation, you will find that y is equal to 3. And it's symmetric. It's symmetric. You went over 1, go over 1 this way. Maintain y value, okay? The next point, if I pick negative 2, you will find that y is 6. And it's symmetric. Over 2, 2, okay? If I pick x to be negative 1, y will be 11, and it's symmetric, okay? Now, I would like to show you something about parabolas that will always work, okay? Graphing these can be an absolute piece of cake if you know where the vertex is, and if the coefficient in front of the squared term is a 1, I'm going to show you a little trick. This always works. From the vertex, over 1, up 1. From that point, over 1, up 3. From this point, over 1, up 5. And then it's symmetric. That pattern, that over 1, up 1, over 1, up 3, over 1, up 5, always works. Okay? Always works. And now you can smooth curve this. Ooh, I missed a little bit there. All right, so that little trick always works if the coefficient in front of the squared term is a 1. Now later we're going to learn that we can pick any coefficient in front of a, and we will still be able to graph this using a common pattern. Okay, so there's my pattern. So there's my parabola, folks. It's all graphed up. So are there any x-axis intercepts? No, there are not. However, I have a vertex, I have an axis of symmetry, I do have a y-axis intercept, and I have no x-axis intercepts. All right. Okay, so hopefully that helps you out a little bit, and you'll be able to use that pattern a little more as you go on. Remember, as long as the coefficient in front of the square term is a 1, that always works. If you know where the vertex is, from the vertex, over 1, up 1. From that point, over 1, up 3. From that point, over 1, up 5. And then remember, it is symmetric. All right, well, that's all I got for you right now. More to follow. So let's get some stuff turned in here and have a wonderful parabolic day. Maze out.